Today we're going to be learning on how do we calculate the surface area of revolution. So in here, I be put the formulas that we need. If it's rotating on the x-axis, the formula that we're going to use is below it, which is we're going to use a to b here. And the y is going to be the radius. I'm gonna use y instead of r of x, which is the uh, radius function, and here if it's x-axis. Now let's try this problem. Y equals to x cubed, and we have its domain here from 0 to 2. So we're going to calculate the area of surface of evolution, the surface of evolution, and it's going to rotate on the x-axis. So how do we do this? So we're just going to use this formula. So the surface area of the revolution is going to be 2 pi, the integral from a to b, multiplied by y, times the square root of the derivative of y with respect to x. We're going to add a 1 plus there and square it, dx. So yeah, let's just plug in everything. So we have 0 to 2, so that's 0 to 2, and we are going to find y. So y is equals to x cubed, so just put it here, and we got 1 plus, so the derivative of this, let's take the derivative of y with respect to x. Okay, so that's going to be the dy dx is equals to, we can just use power rule, so we got 3x squared. Then let's square it now, so we can just plug it in later. We can just plug it in the formula. So taking the square of this, we got dy dx is equals to 3 squared, which is going to be 9, and we're going to multiply x squared times 2, that's going to be x raised to the 4th. So let's just plug it there. So we got 9x raised to the 4th dx. So now we can just use a little bit of manipulation in order to integrate this massive function. So let's say let's use u substitution. That's going to be let u is equal to 1 plus 9x raised to the 4th. So let's take its derivative. So we got 36x raised to the, it's going to be third, yeah, that's going to be third power. Then we're going to put dx. Now we can just divide both sides by 36x cubed. Okay, that should be cube, not fourth power. So the surface area of revolution is equals to, wait, actually we're going to replace the x here from 0 to 2. We're going to change it. We're going to plug in, what are we going to plug in? The value of x into u, its new domain. So we got 1 plus 9, then 2 raised to the 4th power is going to be 16, and we got 9 times 16, so that's going to be 145 if we're going to add the 1. So that's it. Okay, now we have done everything. Just delete this and put the information in our new integral. So now we got 2 pi integral 1 to 145. Well, we know that. So we got x cubed here. We replace this with u. We just put u. And we got du over 3x 36x cubed. That should be u, not raised to the 4th. So yeah, we can just now cancel x cubed here. We'll just delete all of this. So we're going to cancel x cubed. And 36 is a constant, so therefore they just move it outside of the integral sign. So we got the integral of 1 to 145, and we got the square root of u. We can just write it in a fraction form. Okay, now let's just integrate this. So we can just use power rule again. I don't know what is it called anymore, so let's just do it. So we can simplify this, but we're not going to do it. Let's do it later. So we got 1/2 plus 2 over 2, 1 half plus 2 over 2 here, and plus the constant. Actually, we're not going to use a constant, but we're going to integrate. Still, find its value from 1 to 145. So let's make this. Let's simplify this furthermore. So we can just simplify this. This is going to be 18. 18 times 2, right, is 36. So we got, let's put some bracket here. We got u raised to the 3 over 2, 3 over 2, and we're still going to integrate it from 1 to 145. Now we can furthermore simplify this. We can do the keep change flip here. Okay, so we got okay, simplify this. So we got 2/3 multiplied by 3 over 2 from 100 to 145. Okay, now let's multiply. If we multiply it, we will get pi over 27. It's 9 times 2. We just multiply 2/3 to pi over 18, and we're going to simplify it, so that's going to be pi over 27. So now we can just plug in 145 and subtract it to here. If we plug in 1 here, so we got 1. So that's going to be still 1, right? Just put 1. Right, there you have it. Okay, now let's simplify this. So okay, so we got pi over 27, and we're not going to use everything here. We'll just leave it like this. It's too massive, so we can just write it again as 3 over 2, and we're going to subtract it by 1. So I think we leave it as this. You can just plug it in a calculator. Now let's try another problem. So we got y is equals to the square root of 4 minus x squared. So this is a rough sketch of this graph, and it's basically rotating from the x-axis. So let's call this y. So that's going to be the radius. So s is equals to 2 pi square root of a to b. We're still going to use this formula because we have a radius of y, and it's rotating from the x-axis, so we'll multiply this by 1 plus dy dx squared get dx. Okay, now we know the value of y. That's going to be square root of 4 minus x squared. You just put it here, and let's find the value of dy dx. We still do not know that. So we got y is equals to 4 minus x squared, and we're going to take its derivative with respect to x. So let's take the derivative with respect to x. So we just have a 1/2 multiplied by 4 minus x squared. We are using chain rule though. So let's take the derivative of the inside function. That's going to be 0 minus 2x. Okay, let's simplify this. So we get 1/2. We can move this in the denominator. So we got 4 minus x squared. Let's take the square root, or let's just leave it as a function. And we still have the negative 2x, but we can't write it anymore. So dy dx is equals to this. Take its square root. We raise it to the second power. So we can just plug in everywhere. We can just plug it in the formula. So as we can see here that 2 will cancel. So we got x only. We leave us with x. And let's move it in the denominator. So we got square root of 4 minus x squared. Or we can just write this as 4 minus x squared quantity 1/2. Okay, we can just plug it into the equation. So we have a lot of work. But we can still furthermore simplify this though. We take the square root. We take the square of each side, so we're going to distribute the 2. So we have this. Okay, now we can plug it in there. So I hope you remember that because I have taken notes. So got x squared 4 minus x squared. Okay. Okay. Now we can just simplify this. So we got negative 1 to 1. And we can just put 4 minus x squared into the radical sign of the other one. So we got 1 plus x squared 4 minus x squared. And then we can just distribute the 4 minus x squared into the other quantity. So that s equals to 2 pi negative 1 over 2 1 and the square root of, okay, let's just distribute it. So we got 4 minus x squared, and 4 minus x squared will cancel, so leaving us with x squared. And then we can see here that x squared will cancel. We just cancel it, and it leaves us with the square root of 4. So 4 is a perfect square, so we can just make it as 2. So we got 2 pi, and we have negative 1 to 1. The square root of 4 dx. So the square root of 4 is going to be 2. Okay, we have a tremendous work. So we got 2 pi integral from negative 1 to 1, and we have 2 dx. So like we can move 2 to the outside of the integral sign. So we got 4 pi negative 1 1 dx. Okay, so we got 4 pi. Let's take its integral. So we got x. We got negative 1 to 1. Let's just plug it in here on this x variable. So let's just move it here. So we got s. The surface area of revolution is going to be 4 pi multiplied by 1 minus negative 1. Okay, so the surface area of revolution is equal to 4 pi. So 1 plus 1, this is going to be 1 plus 1 though. So we got this, and that's going to be 2. And let's just distribute it to 4. That's going to be 6 pi. So that's going to be our answer. But if you want to see the work, here's how it's done. So 4 times 2 is going to be, 8. Okay, 8 pi. So this is the surface area of revolution. So 8 times 3.14168. You can just plug it in your calculator. Now let's try this one. This is a little bit tougher. So x is equals to 1/3 quantity y squared plus 2 raised to the 3 over 2. So as we can see here that it is rotating from the actually we just flip it up, so it's rotating on the x-axis too. But as we can see here that it's in range. It's 1 to 2. But we're still going to use we're going to use different formula now. So the surface area here is going to be 2 pi. And we have c to d. That's going to be 1 to y is equals to 1 plus dx dy squared. So let's calculate it. So we have x is equals to 1/3 quantity y squared plus 2 raised to the 3 over 2. So let's take it derivative. So we got dx dy is going to be 1/3. We got 3 over 2. We have y squared plus 2. And then let's subtract 1/2 here. Let's subtract 1. So we got 2y. We're going to take the derivative of the inside function. So we got here is this y squared plus 2. We have 1/2. We still have 1/2 here. We got 2y. We can just cancel 2. Let's cancel 2. So dx dy, let's just cancel 2. So that's going to be y squared plus 2 raised to the 1/2. But we're going to take it square. We're going to raise both sides of the equation with the second power. So we got, leaving us with y squared. We can cancel the 2 here. So we have y squared plus 2. Okay, now we can just distribute y squared. So that y raised to the fourth plus 2y squared. Okay, that's a massive work out there. It's a massive algebra. But here's a warning. Differential equation has more into this. Differential equation is much more time consuming to solve. Yeah, that's a warning, or I'm just scaring you. Especially higher order differential equations. Okay. Now we can just furthermore simplify this. So we got 2 pi is 1 to 2 and times y, take square root of. Okay, we just, this is let's arrange this. So that y raised to the fourth plus 2y squared plus 1 dy. Then we can just simplify the radical function. So let's say let a is equals to y squared. So that means that we can just replace it. So that means that we have a squared plus 2a plus 1. Then we can just simplify this. So that we can just make this a plus 1 squared. The perfect square. So therefore we can just write it as quantity a plus 1 squared. Or if I'm going to substitute the y squared into a again, so we get y squared plus 1. Okay, so we have now 2 pi and the integral of 1 to 2. So multiply by y and we got y squared plus 1 squared here. For that will be cancelled. So let's cancel it. So that 2 surface area of revolution is going to be 2 pi from 1 to 2. So multiply it again by y. And the radical sign is cancelled. So we got y squared plus 1 dy. Then what we can do now is just distribute it again. So let's delete this. We don't have enough space. It's a massive problem though. Okay, so we got the surface area of revolution is going to be, it's going to be 2 pi. And we have this integral of 1 to 2. And we get y cubed plus y here. Then we have dy. Okay, we can just distribute dy. So we get 2 pi. Then let's just distribute that dy, and let's distribute the integral sign too. So we got y cubed dy plus the integral from 1 to 2 of y dy. So now let's integrate this. So the surface area is going to be 2 pi multiplied by y raised to the fourth over 4 if we integrate it, but still we're going to find its value from 1 to 2. And the integral of y is going to be y squared over 2, and we're still going to find its value from 1 to 2. So we got 2 pi. So let's plug it in. Let's plug it in into the variable that we have. So I mean we can just factor 1/2 2. So we got y raised to the fourth over 2 plus y squared from 1 to 2. Okay, now I think I'm ready. We are ready to plug in everything. So we can just cancel the 2. So we got 5. Okay, so we got 2 raised to the fourth, 2, and we're going to subtract it by the other one. So that's going to be y raised to the fourth over 2 plus 2 squared. Oh, we do not have a denominator, so we just leave it as that, and then we got y squared. Okay, now let's just simplify this. So let's simplify this massive mess that we made. So s is equals to pi. So this is going to be 2 cubed, but let's simplify more work. So 2 squared is 4. We have y. 1 squared is 1. So s equals to pi, and we can just make this 15 over 2, and we have 3. So we're still going to convert that into fractions. So we got 15 over 2, and 3 times 2, that's going to be 6, and 2. Okay, the surface area of revolution is going to be pi, and then we're going to add this, so 15,621 over 2. So can we simplify this furthermore? So nah, they just write it as 21 pi over 2. So that's the surface area of revolution of this specific function. Now let's try this problem. So y is equal to negative 1/4 x squared plus 1. And we're going to take the surface area of revolution from 0 to 2 on in its x. And it's rotating by the y-axis. So now it's rotating on the y-axis. So we're going to use this formula once again. So we got x and multiplied by the square root of 1 plus dy dx, and let's just square that. So we also have we have dx here. Okay, now let's try this. So if we're going to differentiate, we're going to take the derivative of y with respect to x. So let's do it. So negative 1/4 times 2x. We're just making this quick though. So we got negative 1/2. And then what we're going to do is take the raise it to the second power. Okay, let's raise it to the second power. So let's move it here. So we got dy dx squared, and that's going to be let's just distribute the second power. So we got 1/4 x squared. Okay, let's just put it in our equation now. So what do we have here is the surface area of revolution is going to be 2 pi integral from 0 to 2 times x. We're not going to put anything on x because we doesn't have any given value of x. So we leave out with this. So let's u is equal to 1 plus 1/4 x squared. And let's take its derivative. So we got du. So that's going to be 0. So let's just not put it. So we got 1/2 x dx. Okay, now let's just solve for x. So we got this. So now the surface area is going to be 2 pi and integral from 0 to 2. Actually, we're going to replace it. We're not going to put 0 to 2 anymore. We're going to do some math here. Let's plug in another x value. If you do plug in x equals to 0, so let's say x equals to 0. So that's going to be, I'm deleting things. Okay, so x equals to 0. So we will have 1. So that's going to be our first. And if we're going to plug in 2 in our equation, we're going to get 2. Because we have 1 plus 1. And then it's going to be 2. So we still have 0 to 2 again. Well, I mean 1, 0 is replaced. Okay, now we are done with those things. Now we can just cancel x. So let's cancel x. So we got the integral from 1 to 2. We have the square root of u. Do we have 2 here? Okay, that's going to be 4 pi. Okay, now let's integrate this. So the s equals to 4 pi. And it's going to be u 1/2 plus, let's make this a fraction. So 2 over 2. We have 3 over 2 in the denominator, but we're not going to put it though. And we're still going to plug in the value from 1 to 2. So we got 4 pi here. And u is equals to 3 over 2. And we have 3 over 2 here. We can just flip this up. So we got 2/3. And we're still going to integrate it from 1 to 2. So we can just simplify this. We got 8 here. 8 over 3 pi. U raised to the 3 over 2. We got 1, 2. Okay. Now, let's plug in the value. So we got the S is equals to 8/3 pi. And now let's plug in everything. So we just put a bracket here. So the first one is going to be 2. Okay, let's integrate from 1 to 2. So we got 3 over 2. We're gonna add 1. No, we're not going to add 1. We're going to subtract it by 1. So let's just leave it as 1 because we're not going to do anything there. Just 1. Because if you're going to take the cube root of 1, that's going to be, raise 1 raised to the power is 1, square root of 1 is 1, so just 1. Got 8 third pi. And we have 2 here, and that's going to be 3 over 2 minus 1. So let's simplify this furthermore. 8 thirds pi, and then we can write this in this form. So let's just simplify it. So s equals to 8 third pi brackets square root, and we got 8 1. So I think we leave this at this, but I wanna simplify it furthermore a bit more. So we're going to take the square root of 8, but we can just make this 4 times 2. And 4 is going to be simplified to 2. So we get s equals to 8 third pi. So we got 2 root 2 minus 1. Okay, I think we will leave it as this. Some massive we got. So this is surface area. Now let's try this one. Y is equals to cube root of x. So what we can do here, this is so easy. So we can just solve for x here. So we can make things easier. So we got y cube is equals to x. So we will have this function now. It's still rotating on this plane. I'm going to call this x. And that's it. We just rotate it. They are almost the same thing. So s equals to 2 pi. And we're going to have a 1 to 2 here. So 1 over 2. So we're going to use c to d. And we're going to use x here. So we just solve for x so that this is going to be easy. So this is supposed to be dx dy, not dy dx. So dx dy squared, we have dy here. Okay, so we know the value of x here. That's going to be y cubed because we solve for it. And we actually solve for it because wait, what am I doing? Oh wait, we just made it as x equals to y cubed. Okay, so we got dx dy. That's going to be 3y squared if we're going to differentiate it. And then you're going to take this square root of both sides. So we got y over 4. Okay, so let's plug it into the equation. So we get s equals to 2 pi. And we have 1 to 2 here. And we get x, that's going to be y raised to the 4th now. And it's going to be y cubed. And this is going to be 9y raised to the 4th. So that dy. First, that's popping out here. Okay, now let's solve this. Let's simplify. So just like earlier. So let's let u is equals to 1 plus 9y raised to the fourth power. Okay, let's take its derivative with respect to y. So 36 y cube, and we have dy. And if we're going to solve for y cube here, for dy here, so we got this. Okay, now we can just replace dy by du over 36y cube, and we're going to replace 1 plus 9y raised to the power 4 powers to be u. Okay, actually we're going to replace the values of 1 to 2. So plugging in what we have here, so the new value is going to be 10, and we have 16 times 9 plus 1, that's going to be 145 again. Okay, now let's put it here. Going to be u. Oh, let's just completely delete all of them. So s is equals to 2 pi, and we got 10 over 145. Okay, what do we have? So we got y cube, we still have y cube, and this wall radical is going to be u. So okay, let's just make it u. So we got here now du over 36x y cube. 36y cube. Let's just completely delete all of this. Now we can just cancel the y cube. So we got pi over 18. We just simplify it. We got 10 over 145. So we got u raised to the 1 half du, and we get s equals to pi over 18. So we already know the pattern. That's going to be u raised to the j over 2. I'm going to have 2/3 here. I'm just going to integrate it from 10 to 145. So to find the value from 10 to 145. Okay, so we can just simplify it too. So that's going to be 1 over 27 again. Pi. And plug in the numbers. We got 145. We just leave it like this. And then we'll just minus it by 10. So we got 10 here. 3 over 2. So, I think we leave it like this. If we're going to use calculator, you can. So the answer is going to be 200. It's a exact number. Actually, I'm going to put 200 units squared.